Hi everyone, welcome to Polar Curves. So today's objective, we're going to find the equation of lines that are tangent to the polar curve. We're going to look at one specific example. So what do you need to know here? Well, we're going to use the idea of actually parametric equations to help us find the lines tangent to polar curves. So remember, a parametric equation, x is in the form of r cosine theta and y is written as r sine of theta. The derivative, dy dx, is equal to dy d theta over dx d theta. Now, you can also think about it like this. Now, in the formula in black here, most people are going to tell you that this is hard to memorize. But if you use this derivative, you're actually going to be able to get this piece. And we'll show you later on that you're going to see some similarities. So we're going to concentrate on this derivative of parametric equation in order to help us derive this, okay? Now, in order to write an equation of a tangent line, just like before, you need a point and a slope. So, to find the equation of that tangent line of a polar curve at some point, we use the point-slope formula. So you need the slope and you need the point. So, to do this, we're going to follow these three steps. Okay? The hardest part, depending on who you talk to, the hardest part is going to be finding dy dx. You can find r by using the value of theta if theta is given. Sometimes you have to find theta as well. Then you're going to find x and y using the parametric equations for x and y. So this is generally what I'm going to follow, and we're going to present the example. It's a long example. So I got to thank Integral Calc Girl for this example. Really good example to do for a first example. So find the line tangent to the curve at the given point. R is going to equal cosine 2 theta. Theta is going to equal to pi over 4. So step number one, find dy dx. So dy dx is dy d theta over dx d theta. Okay? So remember that x equals r cosine theta, y equals r sine theta. So in order to do that, I'm going to substitute my r value, or what I have for r, into these equations, these parametric equations. I've done so in black here. Okay? So now, after I substitute cosine 2 theta in for r, I'm going to find the derivative using the product rule. So I'm going to do dx d theta first because it's first in the alphabet, x before y. So here is the first times derivative of the second plus second times derivative of the first, okay? And then I clean this up a little bit. I bring up the negatives, okay? So remember, derivative of cosine is negative sine here, plus the second times derivative of cosine 2 theta is negative 2 sine 2 theta. Okay, so I've cleaned this up. So dx d theta is equal to negative cosine 2 theta times sine theta minus 2 sine 2 theta cosine theta. And we're going to use that later on. Now that should say dy. Looks like we scraped that off a little bit. Dy d theta is going to equal, we're going to do the product rule again. First times derivative of the second minus plus second times derivative of the first. Okay, so I go ahead and do dy dx. Here's the product rule again. So that simplifies to cosine 2 theta cosine theta minus 2 sine 2 theta sine theta. Now, here's that idea. Remember at the beginning in black it was dy d theta, dx d theta. Look how they're very similar here. Okay, so here is the derivative dy dx. Okay, here's dy d theta over dx d theta here. Now what I have to do is substitute my value for theta in. My theta was pi over 4. So what we do is wherever we see theta, there's a pi over 4 that goes in. And notice how you have 2 pi over 4, okay, for some of those. So on the next line, I substitute in. Then I look to the unit circle and find that cosine of pi over 2 is 0. Cosine of pi over 4 is root 2 over 2. And the same goes through all of these. So I simplify. Notice that becomes 0. Those terms are gone. And then we have the same terms being divided, so our slope ends up being 1. dy dx is equal to 1. Second step, now we're going to find r. We're on the home stretch here. Next, we're going to find r with theta being pi over 4. So r was equal to 2 cosine, r equals cosine 2 theta. So I plug in pi over 4 for theta, and I get cosine of pi over 2, which is 0. Step number 3, since now we have r and we have theta, we can find our coordinates, x and y. So here's x and here is y. So I substitute both r and theta in, which I've done in red, 0 and pi over 4. It just so happens in this case that x and y are 0, 0, so we say that we're at the pole. Okay, so x and y are both 0. And last step is now substitution into our point slope formula. So y minus 0 equals 1 times x minus 0. So the equation of the tangent line at that theta pi over 4 is y equals x. So if you have any questions or comments about the polar curve example here and how to find the equation of the tangent line, go ahead and type them below. We'll see you next time.